What's up, Raiders? Just want to talk to you today about a couple of the different ways that you can see a Pythagorean theorem problem. And with Pythagorean theorem, the important thing to remember is what types of triangles it applies to. So first things first, while we've identified a variety of types of triangles, Pythagorean theorem is only going to work if you're dealing with right triangles, and it specifically focuses on side lengths. We know some triangle traits related to their angle measures. Well, Pythagorean theorem is limited to analyzing right triangles, and it's specifically something that focuses on their side lengths. So just a little reminder that first things first, a general point that we've kind of reinforced this year is don't assume anything specific about a diagram just by looking at it. You know, for example, we can assume some general things, like you can look at an angle, and in many cases you can reasonably classify it as being acute, because that's a general classification. You're saying it's less than 90 degrees. But for something like this triangle certainly looks like a candidate to be a right angle, but we're not sure, because that's a very specific trait. You know, 89 degrees or 91 visually probably looks about the same as a 90-degree angle. So don't assume that something like this is a right triangle. You need some official verification. So in this case, we've got the visual there. So okay, now it's a right triangle, and we can use Pythagorean theorem then to analyze its side lengths and how they're related to each other. So the two triangle sides that make up the right angle are legs, leg 1 and leg 2. And then the third diagonal side, that's always the longest side, is the hypotenuse. And so the mathematical relationship that's true for any right triangle is the length of one leg squared plus the length of the other leg squared is going to equal the length of the hypotenuse squared. So generically, it's most commonly written as a squared plus b squared equals c squared. And with the legs, it doesn't matter which one you classify as leg 1 or leg 2, or a or b, it doesn't matter. So let's take a look at the two different ways that this problem can show up. So you can have one situation where you know both leg lengths and the hypotenuse is unknown. So let's say this leg has a length of 5 units. This leg has a length of 9 units. So then we can say 5 squared plus 9 squared equals c squared, c being the hypotenuse. So 5 squared is 25, 9 squared is 81, equals c squared. So 81 plus 25 is 106. So the hypotenuse squared, or c squared, equals 106. We don't want to know what the hypotenuse squared is, we want the hypotenuse. So take the square root of both sides. The square root of c squared, what times itself equals c squared? It's c. That's why we did that. So c, or the length of the hypotenuse, is exactly equal to radical 106, exactly equal to the square root of 106. Now the natural tendency, because in everyday life we don't really refer to numerical values with radical signs. I mean, no one goes to the gas station, looking for the perfect deal where they find gas that's, radical $9.1. So the natural tendency is to want to work this out further in a calculator, and you can certainly do that. If we take the square root of 106, we get approximately 10.3. So notice the distinction there. C, the length of the hypotenuse, is exactly radical 106, or the square root of 106. It's only approximately equal to 10.3. So the natural tendency is to want to work it out that last step in the calculator. And in our heads, a lot of times we want to say, oh, we're going all the way down to decimal places, so that's like exact. But it's not. 10.3 is a rounded off value. Radical 106 is actually the exact length. So it might not feel as comfortable for us in terms of being able to picture that numerical value in our head, but radical 106 is actually the exact length of the hypotenuse. 10.3 is only the approximate length. So we have that sample. Now let's take a look at really the only other way that a right triangle Pythagorean theorem scenario can show up is if the two sides, one of them's a leg and one of them is a hypotenuse. So that could be something like this. So let's say the hypotenuse length is 20, and let's say this length here is 12, and then our unknown is the other leg. So we can call it a squared plus 12 squared equals 20 squared. Leg 1 squared plus leg 2 squared equals hypotenuse squared. And we could have switched these around. We could have called it 12 squared plus b squared. It wouldn't make a difference. So a squared plus 144 equals 400. Subtract 144 from both sides. So a squared, or the length of that leg squared that we're looking for, equals 256. Take the square root of both sides. Well, what times itself equals a squared? A. And then the square root of 256 is exactly 16. So there is no approximate answer in this case. This leg is exactly 16. All right, Raiders, if you have any questions, like always, feel free to contact me on the Remind app.